Yeah, we are going to. I'm trying to record it also because if you want to refresh it and see it again, let me see if it is going to start recording. Says, but I don't know. We have to wait to see if it is going to be. It is start because it should be a red button. Ah, yes, it's okay. Okay, then I will. You are seeing my paper that I am my PowerPoints that I'm sharing with you.
Yes.
Yes, sir, we can see.
Okay, okay. As you see, as I said to you, I'm going to introduce you the descriptive statistics first. Why you are using descriptive statistics? It is important for the economical estimations. I don't know if you did this before, maybe you did. It is not difficult, but it is important to interpret these. Therefore, I want to start from the beginning to make it some comprehensive explanation to see how it is going on. And then we will go to the regression analysis first, and then the program on the EView we will introduce to you. Did you do any regression analysis or any EView application on these classes, or you didn't? Did you do any performance, or you didn't? I want to know. Everybody. Only Zirkullah did, or everybody did?
I don't know about the other there.
I didn't do so.
Okay, that's why I want to refresh you, because partly maybe Zikullah knows, but I have to make it sure that you are knowing this, because in statistical analysis we are using this for increasing the impact of the estimations. Let's start with this, as I said to you, descriptive statistics first, and then go through the some simplest estimations. Mean, media, mode, you know, these are the important estimations and important statistics, which gives us some information about the parameters, being able to estimate in using these models, how it is going to affect and change the impact to the model will be probably helping them to understand the impact. The variance, standard deviation, and skewness are important. And sometimes we are using this for the models before going to start to these estimations. And as you are knowing, or if you don't know, then mean is, of course, in the statistics also given, is sum of the data divided by the number of the data. As you know, it is given in this example, which is 1, 2, 3, 4, 5. You are going to add this together and divide it to the number of n. And this will be then mean, which is the mu in Greek alphabet illustrated with X bar. You know this. And this is then the simplest estimation. And when you are using this, then this will then gives you some information about the statistics, descriptive statistics that we are going to interpret in the model. The media that we are using is the middle number. Either it can be odd numbers or even numbers. If it is odd numbers, it is given in the first example, 1, 2, 3, 4, 5, and the odd is 3, as you see. Then this is then the median, is the middle number, so-called. And if it is even number, then we are going to add this 2 in the middle, then divided 2, then this will then gives us again the media. Okay. You are following?
Yes.
The
Yes,
median is the median is helpful when looking for a house to buy, for example. The median house price is the typical price you will pay, even though the millionaire's house at the corner of the block rises the mean of the house prices above the value most people pay for theirs. Therefore, we are using this kind of simplest statistics, as I said to you, for estimating the impact of these parameters that we are going to include in the estimation, including the model. And the mode is the most populated class or most populated number, as you are seeing here, the 1, 1, 2, 3, 4, 4, and 5, 5, 5. The most repeated one is the 5 here. Therefore, the mode is 5 here. Then we are going to estimate easily this as a mode. And when you are looking to the second example, it is 1.1, 1.2, 1.3, 1.8, 2.0, 2.6, 3.1, 4.6, 4.8, and 5.1. Then the class from 1 to 2 has the most numbers as you are observing here, and the center of this range is 1.5. So the mode is here 1.5. Actually, this is not given here, but this doesn't mean that you are going to see these numbers, but it is, of course, even mostly used numbers will be assumed and accepted in the mode. You see in the graphic also given if the 5 is mostly repeated here and it is used, then we are accepting this in the mode. The center of the tallest bar, so-called. You are observing the graphic here, the 1.2, 2.3, 3 to 4, 4 to 5, and this will then give you the mode. These are not so difficult, I think. And the variance is the power of standard deviation. The power, second power, is the power of 2, as you call it. Standard deviation is the power of 2, and variance is, of course, giving us this. And when we are going to take this example, which is given in the former table, we will see here the 1, 2, 3, 4, 5 is going to be given as x, and x bar is the, as you know, x bar is the mode, and then you are going to give 3, 3, 3, 3, 3. And then when you're going to subtract this x and x minus x bar, then this will then give you the numbers again, minus 2, minus 1, 0, 1, and 2. And then this x minus x bar power of 2, then will give you again 4, 1, 0, 1, and 4. Then the summation is 10. Then when you get this all together, then you will have this denominator, the summation of x minus x bar power of 2, then divided to the n minus 1, which is going to be 10 over 5 minus 1 will be 2.5. This is then the variance. And when you are going to get the standard deviation, this will be the root square for this, then this will make 1.58, as you are observing in the equation, is the root square of this variance, which is going to be summation in bracket x minus x bar power of 2 will be divided to n minus 1. Then this will then gives you this standard deviation. You are happy up to here, you know these things. I think this is not so difficult, so I don't think that it is going to be a problem for you. If you have any question, you will ask me. If you don't, then I will go further. You have any question?
No, sir.
Okay.
No, sir.
The skewness is the distribution of a set of data may have symmetry about the mean, or it may have a longer tail to one side or to the other side. It can be left or to the right. And if the tail point to the right toward positive x value, the skewness will be a positive number. And if the tail points to the left, the skewness will be negative. So this is very important to know, and this will then helping him to understand how it is affecting this in the model. Then it is given here, as you see, to the right skewed right tail. Then this means then you are having here, then you are going to apply this equation to 2.76 minus 1.5 will be divided to 1.56, and this will then give you the skewness. The longer tail to the right or to the left is estimated. Skewness is mean minus mode divided to the standard deviation. This is here given the data. Then we are going to apply and find the skewness. That is mean mode divided standard deviation. These are the same things that we have already exercised. Okay. So I'm going to the next. Then here we have one example for you. Then you are going to put these things by calculating. I will give you 2 minutes time to find the numbers. Then I will then ask you to tell me the numbers. Then we will go further to interpret the economical aspect of this mean, mode, media, variance, standard deviation, and skewness. So you try to do this and tell me the numbers. Then I will see who did what. The given example here. You want to do it?
Sir.
1, 3, 4, 4. I have chosen the number.
What was it? You just tell me the n, the graph, the mean. I mean, tell me your name and tell me the numbers, and I will see whether it is correct. Or you will see. I will move further.
Okay, let me think, and then I will see you.
You can. Do you want me to go back if you want to get the formula?
The other.
Hocam, what was skewness formula?
Skewness formula.
Yes, please.
Yeah. Mean, mode divided standard deviation.
I think I did, sir.
Tell me the numbers.
N9, mean 3,
No control organism.
median 3, mode 4,
Mean 3, you said. Media
3,
3. Mode
mode 4,
4.
variance 16, standard deviation 4, skewness 0.25.
Everybody agree? Everybody finish.
Sir, I have finished.
Tell me.
The N is 9. Mean is 30.
What's your name?
Zekrullah Zalan.
Okay, 9.
Oh, N is 9. Mode is 4. Median is 3. Mean 13.5. In bar graph.
Variance and standard deviation skewness.
For the standard deviation, can you go back, sir? I can't control it.
The formula.
Oh, yes.
Sigma x minus x bar power 2 divided n minus 1. I go. Okay.
I think I'm wrong in two of them.
No problem.
Okay. My variance and standard deviation should be wrong.
No problem.
Okay, sir.
I will put the EView also in front of you, but I think it is better to make first the theory and then the application, isn't it? So this lecture will be introduction to these, and next lecture we will put these things in the EView. How are we going to estimate in the EView, isn't it? Do you like this? I will do this for regression analysis or OLS, ordinary least square method, or some other panel data analysis. Because first the theoretical application or estimation, and then on the EView to apply or to upload your data to the EView. If you don't know, I will show you how you're gonna do this. Do estimation of the unit root analysis, whether it is significant or non-significant. These things will be introduced to you, the probabilities, why it is required, which test is mostly preferred, what for what reasons. These things is important, isn't it? Because you have to choose the right test to estimate. If you are putting the wrong test with wrong, because I have so many students, they are offering me a paper with wrong estimations, with wrong method, because they are not considering these probabilities, or they are not looking to these IO, I1 values, the first differentiation at level in the unit root. These are important. The critical values must be considered for employing any co-integration or other data. If you are doing wrong, then the model will not accept it. You finish or you are going to finish? It's easy. Shall we go on? Or you need time? Do you want me to go on? Bitti mi Ali, yaptınız mı?
Ben tamamım hocam. O standart deviation'da variance düzüm 2 olsun. Standart deviation'da kök 2. O ikisi galiba yanlıştır benim diye düşünürüm. Diğerleri aynıdır zaten.
Skewness kaç dedin? 25 mi?
Eksi 0.25.
Standard deviation. Sir,
Yes, please.
I have told it the sum of them, like the number 3, mean 13.5, medium is
Who is speaking, Zirkullah?
yes, and mode is 4, and the standard deviation is 6.25, and
And skewness?
is 1.52.
1.52.
Yes.
Where? Do you want me to upload the answer? Is anybody who wants to try? Shall we go on?
I have faced with the problem of standard deviation. I couldn't able to find the standard deviation, then I will be find easily the Swig.
We done this, then I will go. Finished. Okay, let's go to the answer. As you see, the number of the example or sample is 9. The mean is 3. Media is 3. Mode is 4. The variance is 2. Standard deviation 1.4 and skewness 0.7 minus 0.7. Is there any problem with this?
No, sir. It's okay.
Now we have another one, continuous data with 1.5, 1.7, 2.4, 2.5. You try again to do these similar estimations with these numbers, whether you are getting the num right or no.
Hocam, what was skewness? The answer of skewness?
Yeah.
Minus, minus
The former.
0.71. Yes, yes.
Yes, 7.
Minus
former one.
0.71.
Yes.
Thank you, sir.
Done it. Finished. Must be Anyway, it's not important. We will go through because actually we are not in a mathematical class. You will see how it is going to be estimated. And you don't need to calculate actually this much, but you have to know at least the logic of this, why you are using this. Okay, I'm going to the answer. Do you have any? Shall I go to the solution? Go to the answers. You want to see the answer?
Yes, sir.
As you see, the mean is 3.3, median 3.1, mode 2.5, variance is 1.81, standard deviation 1.3, skewness 0.6. You see, when you are going to calculate by hands or by calculator, it's not easy. That's why we are using EU. But you have to know at least the way how we are going to estimate and why we are using this and how we are going to estimate these things is important. Therefore, we are giving this theoretical application to you first to understand the logic and then the application in the EU and the interpretation. I suppose we did this on the EU. We have already received the data. We have the tables. And then let's go to the one model. Okay. If you have any question, ask it. And then I will give you one model. Then we will see how it is going to be interpreted. Okay. You have any question?
No, sir.
No, sir.
Okay.
No, thank you.
This is taken from a paper of one of my paper. You see here we are giving some parameters: per capita income, retail trade, value added agriculture, and manufacturing value added. The per capita income is the dependent variable, and the model created on this estimation to see how it is going to affect this manufacturing value added, retail trade, and value added, and how it is impacting this per capita income. But for the estimation here, as you see, we got some information and data from EU estimations, the mean, media, maximum, minimum, standard deviation, skewness, and kurtosis. This is very important to know what is this and how it is affecting the model, how it is going to be more realistic and reliable data estimation. That's the reason we are using this. And when we are looking to the interpretation, you will understand better. I don't give you the numbers here. I don't want to interpret these numbers, but because we are on the online class, and it is not easy to put this table on it and the information or the interpretation of the data, but I will give you at least some information about the impact or effects of this mean mode or standard deviation. Because as I said to you in paper, when you are going to write a paper, it is important to interpret. If you are presenting your results or explaining how it is affecting or why you are using this paper, why you are using these parameters and how it is affecting and changing your parameters is more realistic, or why you choose these parameters to employ for your model is going to be more realistic approach. Therefore, interpretation is becoming more realistic and more important part of this estimations. You are understanding, hopefully. As I said here, when the descriptive statistics in the table are considered, the mean and median values both measure the central tendency of the considered data to compare and determine which data is the better measure to use. Therefore, mean and median values both becomes important in this estimation for being able to understand the impact to the considered parameters, the tendency to the application. And if the selected data are symmetric, then the mean and median values are expected to be similar. That's all, easily. If it is asymmetric, then it is, of course, something differently must be applied. In this study, we considered, as I said to you, per capita income, the value, and the media for manufacturing value added, and for retail trade is higher than the mean, which implies that the skewness is to the left, as it is explained to you. Either it can be left or to the right, and this will then gives you some information about the impact of this considered parameters. And the mean is left of the median, and it is lower. When you are going to look to the numbers, when you are putting on the graphic, then this will then shows you this results, gives you this results. And these parameters are assumed to be asymmetric with a long tail on the left, because the estimated median values is greater than the mean and the negative skewness is observed. Then we are going to this. You see, the mean and media is affecting and changing this model estimation, and it is negatively, and skewness negatively affecting and changing the parameters estimation. You have any question on this? Interpretations, these are very important things for interpreting these parameters, because this will then gives you reason why and how you are going to create and why you use these parameters in this model and why it is affecting each other. The small differences between standard deviation and media is good because it supports the success of estimation. As you see, there is a small difference between standard deviation and media also here. And you look the data. Okay, 1.8, 1.7, 0.03, 0.006. It somehow is parallel 5 and 4. Somehow is not better. And larger differences is the indication of the heterogeneity among residuals, and it is not good. As you see, we have small, and it's good for us, isn't it? For our model. And it is also known that the mode, median, and mean do not coincide in skewed distributions, although their relative positions remain constant, moving away from the peak, from the top, and towards to the tail. The order is always from mode, median, and mean. Mode, median, mean. Let's look. Mode, median, mean. Goes somehow to the tail, the mean, media, and then mode comes to the peak. These are important interpretations for every descriptive statistic when you are using as a starter to your estimations. Then you will then determine whether it is going to be effective and reliable estimation also after when we are using the unit root analysis also. Do you have any question?
No, sir.
This was the starter for us. Next lecture, I will apply this. I will give you one. If you don't know how you're going to apply this data to the eView, I will show you how you're going to apply or upload to the system, to the eView. And then we will estimate descriptive statistics and start to determine and estimate the unit root, the probabilities. If you don't know how it's going to be uploaded to the eView, or if you don't know how it is look like this eView, then I will give you some, let's say, general outlook and general information about it. And then we will employ one simplest model to estimate this statistics, and then the unit root analysis, maybe the ADF, augmented Digi-Fuller, Philip Perron, and some other unit root analysis will be introduced to you to determine whether the probability values is less than 0.05 or more. Because regarding to this probability values, we are determining the model. As you know, regression analysis or OLS analysis always done at level, and therefore we have to control all variables, whether it is I0 or I1, then we determine the test or the method we are going to employ. Is there any question?
No, sir. Thank you.
Or if you are having any, are you agree with me this interpretation and these applications that we are going to introduce to you, or you have any suggestions? Because I don't know where you are and whether you are able to follow up, because sometimes it comes to you maybe very difficult, or sometimes it comes to you very, very easy. I don't know how is your capacity, or how is your level to follow up, because eView is somehow looks like easy, but it is very complicated, and very long methods and tests can be realized and employed for determining, for example, the ARDL model is very long estimations. If you do some wrong estimations and wrong calculations, then this will then create problem to you. Then your model and your estimations and results will become unrealistic and not accepted. Your paper will be then not good. You are understanding I don't know if you are planning to do these things. You are also intending to write papers, isn't it?
Yes, sir.
We have to have an SSCI, sir, to have a PhD.
I know. I can also help you to. I mean, if you want, you can. But you have to. Since you don't know eView, then you have to know eView, isn't it? You have to learn how you are going to upload, because eView is easier. I mean, not easier. It's a compact program. For me, it's easier. For maybe it is a compact program. It is very helping hand, and it is a faster program, because the former version is maybe a little bit complicated, but now it is faster and it is very good develop, especially the eView 10 is very good. I will introduce you step by step, but I think you have to learn the logic. Why, for example, this is maybe the first time introduced to you the interpretations and their impacts to the economical models, isn't it? Because these things are more important than the estimation. You are understanding?
Yes, sir.
These estimations become very important than this paper, than these tables, because everybody get these estimations easily, may be wrong estimated, as you are observing when you are calculating. The simplest also is sometimes leading a wrong estimation, or sometimes is a very nice, good estimations realized and bring you a better paper. Anyway, next lecture, do you want me to introduce you this eView and apply this statistics, this descriptive statistics, and introduce you the unit root analysis, how we are going to upload the data and how we are going to estimate the unit root and the impact of, because before we go into this OLS or regression analysis, it is important to know this, or I will give you the regression analysis as a theoretical, as I have done now, how we are doing this regression in the theoretical aspect and why we are doing this and what is the impact to the economical models. And then I will give you this eView. Do you like this, or you want me to jump up to the eView?
Sir, introduction will be very good because I never used it before.
So you want first theory also, I think, isn't it?
Yes, please,
Yes,
sir, because
that would be better, sir.
Okay, then I will give you first the, let's say, historical version, this regression analysis, why we are doing, how it is interpreted, and what is the impact to the economy. Maybe in one or two parameters we will going to estimate, but in application next lecture, after the next lecture, the eView maybe after the next, or I may give you only a one short lecture to introduce you the eView and then show you how you are going to upload the data, isn't it? To
Hocam,
take the first differentiation, then after then, because you have to make some exercises, I will ask you some, I will give you some time to show me whether you are able to, let's say, perform these applications or uploading this data and taking the first differentiation. And then after then, I will give you this unit root and regression analysis. Yes, please.
hocam, I'm talking to behalf of myself, but I think it also the same for the Zikrullah. Although we have done ARDL and unit roots in our thesis, we don't technically know what they are. We practically know them. We know them on the system. We don't really know what they mean. We know how to read the tables, but how the tables come up is like magic for us.
The magic. So you know, but in other data, not here, not eView,
Yes,
isn't
but
it?
we know the codes, we know the tables, but we don't know technically what does it do mathematically to conclude that.
Not mathematical, economical, or somehow
Econometrically.
financially, as we did in the descriptive statistics, isn't it?
Yes.
Because
yes.
interpretation is becoming more important. Estimation is something. Correct estimation is more important, because if, as I said to you, if you are making, for example, OLS with I1, this will be a wrong estimation. Many students in my PhD class doing some vector error with I0. which it should be I1, isn't it? They are making some misunderstanding, misleading calculations, or they are not knowing the differences between the restricted and unrestricted. Well, this should be clearly introduced, and also interpretation of the data is becoming more eligible. Therefore, I think I have to give you also first, since you don't know, and I mean some students don't know the EView, definitely nothing. Then I will give you first one regression, introduce you mathematically how it is, why it is the logic, why we are doing this regression, isn't it? And how it is applied
sir.
to the graphic.
Yes, sir.
What is the impact every next year contribution to the economy, for example, because I am economy professor and I am using this for economical aspects. You may be not from the economics department, maybe business. Business is also microeconomics is also very good. I don't know, you didn't get any micro courses, or did you get any micro PhD course?
I just took microeconomics in normal degree, sir.
Micro in
Yes.
undergraduate, in undergraduate.
Yeah, undergraduate, yes.
Because since you are in business, are
Yes,
you in
sir.
business?
Yes, I was
Well,
Yes,
doing
yes, sir.
international
All of us.
business.
You know, I will ask them to open one micro class for PhD. Then I will give you some micro class, because you have to know estimations and you have to know the calculations in the business, because only theoretical estimations or theoretical introduction or the let's say primitive knowledge in micro will not help you to write paper. You are understanding this is very important. You have to know some micro introduction, let's say micro estimation and micro economical theories for being able to combine your calculations and interpret them. Therefore, you have to know first the microeconomics properly. In business department, unfortunately, some universities removing this micro and macro maybe in economics, but this is not good, or managerial economics must be introduced to you, because in business, this is very important. You are understanding in any tutorial job also, this is necessary. If you don't know to interpret your model or your data, this is nothing. You are not mathematics instructor, or you will not be a teacher in mathematics. Therefore, estimating only paper, only the tables and writing some notes below on it doesn't make sense, will not help you to publish it. Okay, then next lecture, as I said to you, I will give you some theoretical introduction to the regression analysis, because these things will help you to understand, isn't it, why we are doing this, or what is the mean of this in the economy, how it is going to be effective and impact to the other parameters, or why they are correlated or not correlated. These things very important for your papers. Okay. Then
Okay,
next lecture, I will give you this. And after this, then do you want me to send you some data? And we will, do you have program, or you don't have this eView? If you don't have the eView, then I will open it and show you, and I will upload these videos also after the class to the system, then you will repeat it. Or I have my YouTube channel, sorry. Then you will take it here, then read it or listen and watch and exercise it, and you will memorize it easily. Is that okay? I think this is the easiest way, because you have to do it. We also sometimes take notes to follow up these estimations, because it is sometimes very long, as in ARDL or in vector error, in restricted or unrestricted. When you are doing such estimation, it needs to follow the guideline. If you miss one part, then you will estimate, or you go to the wrong direction, and this is not good. These things are important. Okay, then next lecture, as I said to you, we will do this, and then we will see how we are going to improve our capacity. Do you have any
Hocam,
question? Any extra? Yes, please.
Hocam, for the last today we were late because of technical difficulties. So next week we'll be starting at 17:30. Yes.
Next week.
Next
Or
week,
this week?
because no. This week we are late, but next week we will be on time, I guess.
Yeah, 5 at 5 if you want. Is that okay for you all? 5 at 5?
5:30.
5 is
5:30.
okay.
5 or 5:30?
Sir,
5:30.
5:30 will be better because I get out of my job at 5. Is that okay for you guys?
I'm good.
Okay.
Thank you.
5:30?
Yes, sir.
Okay. Then see you next week then.
Thank you,
If
sir.
you
Thank you,
have
sir.
if you have any question, then you can write me email, or you can get the number from your assistant Ali and communicate with WhatsApp. Okay.
Okay, sir.
Thank you. Bye bye.
Bye-bye.
Thank you. Bye-bye.
Thank you, sir.
Bye bye.
عاودت انت تفاصيل دي تختلف.
Thank you, sir.